In this video, I'm going to show you how to develop a digital twin solution from scratch using the Azure Digital Twin service. And for demonstration, I'm going to develop a digital twin for my Raspberry Pi here that is measuring temperature and humidity using a DHT11 sensor. I'm going to begin by introducing you to the concept of a digital twin. I'll then show you how to use the Azure Digital Twins definition language to create a model, and then I'll show you how to set up your Azure Digital Twins instance on Azure Cloud, how to use Azure Digital Twins Explorer to create and manage digital twins, and then finally show you how to use IoT Hub and Azure Functions to update your twin with real sensor data. Quick thank you to our sponsors. This video is made possible by HiveMQ, providers of an MQTT message broker. Please do check them out to help support this channel. My name is Kutsayamandi Teresa with Industry 4.0.tv, and I regularly publish Industry 4.0 and Internet of Things tutorials on this channel. So make sure to subscribe to never miss any of the videos. So what is Azure Digital Twins? In a nutshell, Azure Digital Twins is a platform that enables you to create and interact with real-world entities in the digital space. And more generally, a digital twin is a virtual representation of a physical object or system, such as a pump, a car, a building, a factory, or a production process itself. The main aim with the digital twin is to create a digital copy of a physical object such that it can receive inputs from sensors gathering data from the object. And because of this input, which is a continuous stream of real-time data, the digital copy is always in sync with its physical counterpart, making it possible to apply technologies like machine learning on the copy in order to produce predictions and simulations. Now, how do we create a digital twin? Let's say, for example, we have a compressor in a factory floor as our physical object, and that compressor has instruments for measuring things like motor temperature, vibration, and motor current. If we wanted to create a digital twin for it, we would first of all create a model of what our compressor looks like in terms of its structural composition, its technical properties, and its measured physical parameters such as the temperature, current, and vibration. We would then store that model in a digital format and then use it to create a digital twin of our compressor, connect the digital twin to the real-world compressor using some communication mechanism, and then continuously update it with data from the physical compressor. And then, if we wanted to create a digital twin for a separate compressor of the same type in the factory floor, we would use the same model to create another instance and connect it to its physical counterpart. But how do we actually create a model of a physical object? Well, there are a number of methods that you could use, but Azure Digital Twins uses what is called the Digital Twins Definition Language, or DTDL in short. Now, while the Digital Twins Definition Language was created by Microsoft for its Azure platform, they've since brought it to organizations such as the Digital Twin Consortium. Let us take a look at how the Digital Twins Definition Language works and how we can use it to create a model for a digital twin. Now, the Digital Twins Definition Language uses an open language called JSON-LD, which is similar to JSON. But before we dive into the language syntax, I want to first describe to you DTDL's proposition of what the representation of a physical object must be composed of. Now, in DTDL, a digital twin model is composed of 4 key elements: properties, telemetry, components, and relationships, whereby a property represents the state of that physical entity. Using our compressor example, a property could be its name, its power rating, its serial number, and its color. Properties of a model require a storage mechanism that will retain the data permanently and allow for it to be updated as required. And then model telemetry is an event stream representing measurement of physical parameters, and these are normally sensor readings like motor temperature, vibration, and motor current. However, telemetry is not stored on the digital twin. It is processed as it arrives and sent to an external system if required. Next, components of a model are for when you want to include separate models as part of your model. For example, a motor could very well be defined as a standalone model and then used as a component of a compressor model through referencing. And then we have relationships, which let you define how your digital twin is related to other digital twins. For example, a factory floor digital twin would be related to a production line digital twin in that it contains the production line. And an air compressor would be related to a control unit in that it supplies pressure to it, and so on. Now, connecting digital twins via relationships in this manner results in a set of digital twins forming what is called a twin graph. A twin graph, sometimes called a knowledge graph, represents physical entities in your entire environment while reflecting their interactions. And then finally, all the elements of a digital twin model are enclosed in what is called an interface. Now let's take a look at how to use DTDL to create an actual digital twin model. So for demonstration, we're going to assume that my Raspberry Pi with its temperature and humidity measurements is a factory. And so we will be creating a digital twin model for a factory. So digital twin models can be written in any text editor and saved using the .json extension. In this example, I'm going to use Visual Studio Code. So I've got my Visual Studio Code open here. So the first required item is the digital twin model identifier. And here I have it as demo:factory. And this one here is the version of my factory model. And because we're going to be enclosing all elements of our model here, we specify this as interface type, which is also a required item. Next, we have the display name item, which is a user-friendly way of displaying our model name. And then we have the context, which is used to process this interface, and it must always be set to this value. Now here we put all of the items of my factory digital twin model inside the contents. The first item is the temperature, which is of type property, and its schema is double. The schema can be of primitive types such as integer, double, string, or boolean, and it can also be of complex types like object, enum, and map. Now here I'm using property type for temperature because I want this value to be stored on my digital twin so that we can read it later on in this demo. Because remember that telemetry type doesn't get stored. It is processed as it arrives, and if you need to react to it, you send it to an external platform such as time series insights. The second item is humidity, which is also of type property and double schema. Now this is a basic model, but we could add things like relationships and components. So here you can see that the name of our relationship is called contains, and the target is line, which is a production line. And then here you can see that the name of our component is a compressor, but we're going to keep it simple for now. You can check out the DTDL specification on GitHub using the link in the description below for more examples of working with DTDL. So this model of our factory is what we would call a custom model. However, you could use what are called ontologies, which are basically pre-built models for specific industries. Ontologies are actually an ongoing effort. To get a sense of what they entail, you can check out Digital Twins definition language ontology for smart cities, which I've also linked down below. Okay, so once you've finished creating your model, you need to upload it to your Azure Digital Twins instance on Azure Cloud to make it available for creating twins in the digital space. So let's head over to my Azure portal to create an Azure Digital Twins instance. Okay, so now I'm going to show you how to create a new Azure Digital Twins instance on the Azure portal. And as you can see, I'm already logged into my Azure portal. Now I'm going to select create a resource, search for Azure Digital Twins, select it, and then go ahead and click create. So here I'll select my subscription and then create a new resource group. So I'll call it Industry 40 TV Azure Digital Twins. and then select OK. And then I'll select the location and then give my Azure Digital Twins instance a name. So I'll call it my demo ADT instance. And then click on review and create. And then after reviewing the details, I'll select create. Okay, so my Azure Digital Twins instance is being deployed. Okay, so my deployment is complete. So I'll select go to resource. And then here, I'll take note of my Azure Digital Twins instance name, its host name, and its resource group. Okay, so my Azure Digital Twins instance is now up and running. Okay, so now because the account that I'm currently signed in with here is a Microsoft account, I won't be able to access my Azure Digital Twin instance from a client application. So I need to set up user access permissions for a corporate account. And to do that, I'll go on access control IAM here. And then I'll click on add role assignment. And then here I'll select Azure Digital Twins owner. And then I'll leave this one. And then here I'll use this on Microsoft.com account, which I normally use for my Azure Sphere connections. Okay, and then you can see here it appears as selected. And then I'll click on save. Okay, so if we go to role assignments here, you can see that I've got my corporate email here assigned as Azure Digital Twins data owner. Okay, so we've successfully created our Azure Digital Twins instance and assigned user access role that would allow us to manage our instance. Now, when you need to interact with your Azure Digital Twins instance, you mainly use Azure Digital Twins APIs and SDKs for languages such as C#, Java, Python, JavaScript, and Go. What this means is that in order to upload models to your instance, delete them, create digital twins using your models, query your digital twins, and create relationships, etc., you'd have to develop client applications using the APIs and SDKs that I've just mentioned. And there are samples to help you do that. However, Microsoft developed a simple Node.js client application called Azure Digital Twins Explorer, which allows us to use its graphical interface to interact with our Azure Digital Twins instance to perform things like uploading and exploring models, uploading and editing graphs of twins, running queries against the twins graph, and visualizing the twins graph, etc. With that said, what I'm going to show you next is how to perform some of those functionalities against our Azure Digital Twins instance using the Azure Digital Twins Explorer. So the first thing that we need to do is to download and run the Azure Digital Twins Explorer sample code. But before you download it, you need to make sure that you've got Node.js version 10 or later installed on your machine. Okay, so to download the sample app, you go to this GitHub repo, which I've also linked in the description below. Under code here, you can select download zip. So I've already downloaded this and extracted it on my C drive here. Now, before you run the app, you've got to make sure that you've signed into your Azure account using your machine, because the Azure Digital Twin Explorer app depends on the host machine's Azure credentials. The only thing that we're going to input directly on the Azure Digital Twin Explorer is the host name of our Azure Digital Twin instance, which we noted earlier after deployment of the instance. So I'll log in using my Visual Studio Code. And then I'll select my on Microsoft.com account. And now I'm signed into my Azure account. Okay, so let's open up our extracted folder. So here we go into client and then into source. We copy the path, open command prompt, and then cd into our source folder. And then once we're here, we run the npm install command to retrieve all dependencies of this sample app. Okay, when that is done, you run npm run start to start the Azure Digital Twin Explorer app. Okay, so we have successfully run our Azure Digital Twins Explorer app. Okay, so now I need to put the host name of my Azure Digital Twin instance here. So I'll go to my Azure portal. And then here I'll copy the host name. Then I'll add HTTPS here. And then select save. Okay, so what it means is that I've successfully connected my Azure Digital Twins Explorer to my Azure Digital Twins instance. Now, to upload your model using the Azure Digital Twins Explorer, you click on this upload icon here, and then browse to the JSON file containing your model. Then select open. Okay, our model has been uploaded. Now you can select to see your model information by clicking this icon here. And you can see that this is the model that we designed earlier. Okay, so now we need to create our factory twin using this model. And to do that, you click on the plus button here. So we'll call this twin factory 04/2021 because the name has to be unique. And then I'll save this. And then if I select the twin here on the canvas, you can see its properties here. So you can see here we've got an initial value of 0 for our temperature and humidity, which you can adjust if you wish. Okay, so we've successfully created our factory digital twin using our factory model. Now in this area here, you can actually run queries against your digital twins. So for example, if I set the humidity of my factory digital twin to say 54 and the temperature to 28 and then save. Okay, so now here, if I run a query to get the twins whose humidity is greater than 60, I get nothing. As you can see, no results found. But if I say less than 60, I get that factory digital twin because our humidity is at 54. So I'll reset these to 0. Okay, so now I'm going to show you how to send real sensor data to our factory digital twin. So how it works is that we'll have our Raspberry Pi publishing messages to an IoT Hub, and then we'll have an Azure function catching these messages and ingesting them into our factory digital twin. So the first step for us is to create an IoT Hub. So let's go ahead and do that. So I'll go to my Azure portal. And then here I'll select create a resource. search for IoT Hub, select create, and then here under resource group, I'll select this Industry 40 TV Azure Digital Twins resource group, and then I'll select the region, and then I'll call my IoT Hub my Azure Digital Twins IoT Hub, and then I'll select review and create, and then I'll go ahead and select create. Okay, so my IoT Hub deployment is complete. So I'll go ahead and select go to resource. Okay, so now here I want to create a device. So I'll select on new here. Now the device ID here has to be the same name as our digital twin, which is Factory 04 2021. So I'll go ahead and put that in. And then I'll leave everything as default. Select save. Okay, so my IoT Hub device has been successfully created. Now the next step is to create an Azure function. And to do that, we're going to use Visual Studio. So I'll go ahead and open it up. So here I'll select on create a new project. And then here I'll type Azure Functions. Select that and click next. And then I'll call it Factory Twin Ingest Function. And then select create. And then here I'll select Event Grid Trigger. Click on create. Now for my function to interact with the Azure Digital Twins, I need to use the Azure Digital Twins SDK. And to do that, I'll include some NuGet packages on my project. So I'll include Azure.digitaltwins.core. I'll go ahead and install that. And then I'll also include Azure.identity. Followed by system.net.http. And then finally I'll add Azure.core. Okay, and then in my function1.c# file, I'll add the following assembly reference. Okay, now we need to add our authentication code that would allow our Azure Functions app to access our Azure Digital Twins instance. So here, as you can see, we'll be reading our Azure Digital Twins service URL as an environment variable, which we'll configure later on our Azure portal. And then we create an instance of HTTP client. And then inside our function here, we add the code for managed identity credentials. And then we instantiate our Azure Digital Twins client. And then after that, we highlight that our connection has been created. Okay, now if we receive data from IoT Hub, we log the data, convert the message into a JSON object, and then we get our device ID, temperature and humidity from the object, and then we log the temperature and humidity. And then finally, we update our factory digital twin with the temperature and humidity from our Raspberry Pi. And then we make our method asynchronous. Now we'll get rid of this and then enclose our logic in a try-catch block. And then if there's an error in ingesting into our digital twin, we log the message here. And then in the event that our Azure Digital Twins instance is not configured as an environment variable, we need to log an error. So I'll put this statement here. Okay, and then we can call this function IoT Hub to Twins. Okay, and then we can go ahead and publish this app. I'll select publish to Microsoft Cloud, click next, and then here I'll leave Windows as default, click next. So my subscription name here is already selected. So I'll go ahead and click on the plus sign to create a new function. So I'll leave this name here as default. Make sure my correct subscription is selected. And then I'll select my resource group, which is Industry 40 TV Azure Digital Twins. And then I'll leave my plan type as consumption. Then I'll select a location, and then I'll create a new Azure storage here. Select a location and leave the account type as default. Click OK, and then I'll select create. Okay, here I'll click finish. Okay, and then I'll go ahead and click on publish. Okay, so we've successfully published our function app to Azure. So let's head over to our Azure portal to confirm that. So here we'll search for factory twin, and you see it pop up here. So we'll go ahead and select it. And then if we go under functions here, you can see there is our IoT Hub to Twins function. Okay, now the next step is to set up security access for our Azure Function App in order to grant it access to our Azure Cloud Services without using credentials in code. And for that, we use what is called a system assigned managed identity. So to do that, we go to identity here. and make sure that the status is set to on. Select Azure Role Assignments. Add a new role assignment. And then here under Scope, I'll select Resource Group. I'll leave my subscription as default. And then my resource group is already selected for me. And then here for the role, I'll select Azure Digital Twins Data Owner. And then I'll save the assignment settings. Okay, so now as mentioned earlier, we need to set an environment variable to make the URL of our Azure Digital Twins instance accessible to our Function app. And to do that, we first need to go to our Azure Digital Twins instance. Copy the host name. And then go back to our Function app. And then under our Function app, we'll select Configuration. And select New Application Setting. And then here we add the name ADT Service URL. Now, if you remember, that's the name that we used for our Azure Digital Twin instance URL in the code of our Function app. And then under value here, I'll paste the host name of my Azure Digital Twins instance. And then I need to add an HTTPS here. Click OK. Okay, so you can see here our ADT service URL is now appearing on the list. So we save our configuration settings and then continue. Okay, so we've successfully set up security access for our Function app and configured its application settings. Okay, now let's connect our Function app to our IoT Hub. And to do that, we need to set up our IoT Hub to send device messages coming from the Raspberry Pi to our Function app as events. So I'll navigate to my IoT Hub instance that I created earlier. Under my IoT Hub, I'll select Events and then click to create an event subscription. For the name, I'll put ADT Event Subscription. For the event schema, you leave it as Event Grid Schema. And then for the topic, I'll put ADT System Topic. And then for filter to event types, you select Device Telemetry. And then for our endpoint type, we select Azure Function. And then click on Endpoint to select the actual endpoint. And then on this page here, I'll leave the subscription as default and also the resource group. I'll also leave my Function app as default and also the slot as production. And then finally, I'll make sure that the function which I named IoT Hub to Twins is selected here under Function. And then I'll confirm my selection and then click on Create. Okay, so it seems I need to first register Event Grid as a resource provider under my account. Okay, so I'll search for subscriptions here. Select subscriptions and then select my subscription. And then here I'll select resource providers. Okay, so as you can see, most of the resource providers are registered by default, but it so happens that Event Grid is not registered by default. So you need to register it. So there is our Event Grid. If you select it and then click on register. Okay, so now my Event Grid is successfully registered and appearing here on the list. Okay, so we will go ahead and create. Okay, and then if we go to event subscriptions, you can see there our Azure Digital Twin event subscription is now appearing. Okay, so we've successfully connected our IoT Hub to our Azure Function App by creating an event subscription. The next thing that we're going to do is to update our digital twin from our Raspberry Pi by sending sensor data to Azure IoT Hub. Okay, so here I've got my DHT11 temperature and humidity sensor data connected to my Raspberry Pi, and my Raspberry Pi is running a UWP application on Windows IoT Core, which is collecting this temperature and humidity data and sending it to my IoT Hub so as to update the temperature and humidity properties of our factory digital twin via our Function app. Now you can do this using Python, Node-RED or whatever, it doesn't matter. The idea is to publish data to an IoT Hub that is connected to your Function app. So let's head over to my Visual Studio so that I can walk you through the C# application running on my Pi. Okay, so this is my C# UWP application running on my Raspberry Pi. I'll link the source codes in the description below. Okay, so I'm currently running in debug mode here. So this is the main page. I start here by calling the update factory digital twin method, which calls the method for sending sensor data to the IoT Hub. Okay, so let's go to the class that does the reading and sending of sensor data. Okay, so these here are DHT11 variables. I'm reading the sensor at GPIO pin number 4. And this is my IoT Hub connection string. And here is my device connection string. So here you'll notice the ID of the device which I created on my IoT Hub earlier, called Factory 04 2021, which is also the same ID as that of the factory digital twin that we created from our model. And then inside our method here, I first set my GPIO pin as an input pin. I then instantiate an Azure device client using my device connection string. And then I read the temperature and humidity from the DHT11 sensor, convert the sensor values to JSON, and then send the events to IoT Hub. And then we repeat the cycle after every 5 seconds. Okay, so now if I go to my Azure portal here, and then go into my IoT Hub, you can see here that we're publishing messages to the IoT Hub. And then if I go to events, you can see here that we're registering events. Okay, so now I'll pull up my Azure Digital Twin Explorer. Okay, so as you can see, it's currently set here at 0. So if I run query, you can see that we're starting to get updated information from our Raspberry Pi. If I run query again, And again. Okay, I'm gonna have to breathe into my sensor here to increase the temperature and humidity. Okay, you can see we're starting to detect a rise in humidity. If I run query again, you see now we're back to 88. So all of this information is coming from our Azure Digital Twin. Okay, so we've successfully created a digital twin solution for our demo factory using the Azure Digital Twins service. Thanks for watching.